Yes, students, in last video I was explaining formation of PN junction. I told there that due to majority charge density in P region is higher than N region, and due to concentration difference, holes diffuse from P to N region, electron from N to P region, and this diffusion depletes. Actually, this diffusion takes place in the region around the junction, and a layer is created around the junction in which majority charge carrier are depleted, means removed, and majority charge carrier are not present in this region. The diffusion of electron and hole here creates net positive charge and negative charge in the depletion layer, positive charge on N side, negative charge on P side, and this creates electric field. This electric field is very large. Of the I told you 10 to the power 6 volt per meter. The potential difference appears due to formation of charge of nearly 0.5 or 0.6 volt. So, and now this electric field is called, I told, junction field. So initially diffusion current, the junction field drifts minority charge carrier, minority charge carrier, means holes are drifted from N to P region and electron from P to N region near the boundary. The junction field drifts the minority charge carrier, and hence a drift current is produced. Means net positive charge flow from N to P region. Initially, due to diffusion of majority charge carrier. Majority charge carrier means whole electrons. Here majority charge carrier whole, here electron. There is diffusion current. In the starting, diffusion current is greater than drift current. So a net flow of charge takes place across the junction. Across the junction. very soon due to the greater value of diffusion current, junction electric field, junction electric field keeps on increasing, and hence drift current increases. After a while, the two currents diffusion current and drift current become equal. Hence, no net flow of charge takes place. Junction electric field has very important role. I will be discussing later on, but here it helps in maintaining an equilibrium. Further, we can also say that due to junction field, potential difference across the junction opposes the net flow of charge. And this potential difference is called potential barrier. In equilibrium, when diffusion current, drift current become equal opposite, so direct PN junction is formed. है ना? When equilibrium is achieved, the PN junction is formed. PN junction is said to be formed. So I explained that this PN junction is developed on wafer. Initially, we may have any wafer, say, suppose we have p-type wafer. So we diffuse pentavalent element by different method and create two regions, one having majority of electrons and other having majority of one having majority of holes, other electrons, and there is a boundary between the two which is called junction. And due to majority charge carrier, diffusion starts, and due to diffusion net positive charge start developing across junction, which create a potential difference and hence electric field. That electric field is called junction field, and the junction field here drifts. Minority charge carrier, remember, minority charge carrier are drifted by junction field, while diffusion current is because of concentration difference. What is that? This side hole are greater, here holes are small. यहाँ पर hole भी है because of intrinsic charge carrier density. By silicon we have origin taken silicon or germanium. Pure semiconductor has equal number of electron and hole. The number gets changed when we drop the pure semiconductor. So there are holes, but they are small in number in comparison to this region. So due to that difference of hole in the two region or electron in two region, diffusion starts. That diffusion creates electric field which drifts minority charge carrier. So two current start flowing in opposite direction. One diffusion current, other drift current. And initially diffusion current is stronger than greater than drift current, but very soon they become equal opposite and junction is obtained. A PN junction, and when it is obtained, we either paint here metal and connect wire to this for application. The circuit symbol of PN junction is like this. This is the PN junction. These are two electrodes here. One is this represent N junction, is represent P region. PN junction represented by this. But remember, PN junction basically is a small cylinder having like this. Then how do we distinguish which side P region, which side N region? Here is a circular ring, bright ring of some material. That bright ring make it कि ये P region है N region है. So it is very small in size. ये थोड़ा और छोटा हो गया इसका निट, इससे थोड़ा और बड़ा. Now we have different type of diodes. I will discuss later on. So main thing is that it has two electrodes, this one and this one, and hence it is also called a PN junction diode. Depletion region, width of depletion, yes, important thing here. Width of depletion region depend on dopant concentration. Higher the dopant concentration, thinner. Yeah, क्या कहूँ, higher the dopant concentration of P and regions. Thinner the depletion, the depletion layer. Why it is so? Because from a small region, the number of required electron hole depleted will create net junction field which is required to maintain equilibrium, and vice versa. Vice versa means smaller the dopant concentration, thicker the depletion layer. So this circuit symbol, this is the formation of etc. In some books, actually this potential difference is shown. P region at lower voltage and N region at high voltage. This is the potential difference. This difference height represent potential difference between P region and N region. In NCERT book, this graph is also shown. Now in coming video, I will be telling first of all use of PN junction diode and biasing of PN junction. I can explain it here. Yes, biasing. Biasing of PN junction. Forward biasing. Suppose it is PN junction, it is depletion layer, P region and region. In forward biasing, we connect P region to positive terminal and negative terminal. We can vary this voltage. This is called forward biasing. During forward biasing, holes are repelled towards N region, electrons towards P region, and width of depletion layer decreases. Finally, it will become thinner. Initially, this potential difference applied here remain less than, when it remains less than potential barrier, then no hole or electron will jump across the depletion layer and hence no current will flow. If the potential difference applied of the battery is less than potential barrier, no current flows, and you know it is nearly 0.5 volt. About 2. It varies in 2.7 volt. So, if the applied voltage is less than potential barrier, no current flows. But when we increase this voltage and it becomes more than this, holes start jumping from P to N and electron from N to P, and current start flowing this way. This current increase rapidly. If we plot graph here, anode potential, anode voltage. Actually, this is called anode here, and current in milliampere. In milliampere. it is here 1 volt, 2 volt and 3 volt. It will be in volt only. So very soon this up to 0.6 volt it becomes 0, remain 0, and then it start increasing like this. Here this is called knee point. This voltage is called knee point. As the voltage become more than knee point, current increase very rapidly. 5, 10, 15, 20 milliampere. And near the knee point, actually resistance, delta V upon delta I here. Here resistance very large. Below this 0.5 volt, current remains 0, infinite resistance. Then current resistance start decreasing and then becomes almost 0 above knee point. Above knee point, the current resistance becomes 0. So in forward biasing, the P region giving higher voltage than this. Now reverse biasing. Reverse biasing. In reverse biasing, it is PN junction here. P region, N region, depletion layer. We connect negative terminal to P region, positive So initially, as soon as we close the circuit, the majority charge carrier electron here get collected to this and hold to this. So that way width of depletion layer increases, and after a while current becomes 0, no current flows. But when we increase this anode, this is plus. Actually, longer line represent positive terminal, shorter negative terminal. So the reverse bias current, now current whatsoever is there is this. A small current will be flowing there because of minority charge carrier. Minority कौन से होंगे यहाँ? Holes हैं यहाँ पर holes. यहाँ electron हैं. Electron are minority charge carrier. They will go this side and hold this. So a small current will keep on flowing. Sometimes the current is so small that our galvanometer cannot measure. So it will be in microampere order. And -2, -4, -6, -8 volt like this. And it will keep on decreasing in a small current. When this potential difference becomes very large, the material of the diode in the depletion may get ionized and a large current flows. Then this current become independent of potential difference applied, and this is called electrical breakdown takes place, and this voltage breakdown voltage. After breakdown voltage, current become independent, and it is in microampere, reverse bias current in microampere. But if diode is within the breakdown voltage, current is very small, almost negligibly small, and we say in reverse bias it has a offer large resistance. Diode offer large resistance and almost no current flows in reverse bias. So this was all about biasing. Now I will explain you how to study characteristics of PN junction in next video. Thank you. Please watch the video carefully, like and share this video with your friends.